Okay, so we are going to go over just the first couple problems in topic 7.7, calculating equilibrium constants. And remember that previously to this, what you probably were doing was you were looking at, you were given values of concentrations at equilibrium, and then you were just calculating K. Because remember, for what most students think is that, by the way, my hands have a lot of food coloring on them, so they're blue. But anyway, A plus B goes to C. And most students assume that in every chemical reaction, A and B react to completion, and at the end of the reaction, all I'm going to have is C. But what you're learning in this unit, that's not always the case. That some species, the reactants and products are in equilibrium with each other, which means there's a little bit of reactants and a little bit of products at the end of the reaction time. So now I've got a problem, because at the end of the reaction, I'm not going to have just C, I'm going to have A, B, and C. And so you're going to be asked to calculate what those concentrations are and use those to calculate K, or you're going to be given K and you're going to have to find out what the concentrations are of your species. Now, the best way to do this is what's called a rice table. So it says here, one way to approach solving these types of problems is to use an ice table. I call it a rice table, and I'll show you why in a minute. It stands for, R stands for reaction, I stands for initial, C stands for a change with the coefficient, and E stands for equilibrium. Because basically what happens is I'm going to take my reactants that I have concentrations of, that I know because I did that in the lab, throw them in a beaker, let's say. They're going to go through a change in concentration. A and B are going to go away. C is going to appear. And then I'm going to have new equilibrium concentrations at the end. All right? So, the first problem says, given this, here's my reaction. A plus 2B goes to 4C. Your initial concentration of A and B is 1 molar, and the equilibrium concentration of C is 0.20 molar. What is the value for K? So basically, to find K, what is it I need? I need all 3 equilibrium concentrations, because my value for K is going to be products with the coefficient divided by reactants with the coefficient. All right, I've got this, but I don't have this and this. So what I have to do, if this is my goal to calculate K, I'm going to have to find what the concentrations of A and B are at equilibrium, because all I have are their initial concentrations, and that is not the same. So be careful when you are solving for K. Initial concentration, you cannot calculate an equilibrium constant. You must have your equilibrium concentrations at the end of the reaction. So what we do is we use these things called rice tables. So I'm going to put reaction here. So I'm going to write this all. I always go R-I-C-E, and I'm going to put the table like this. So this is where my reaction is going to go. Like that. All right, now if you want, you can put lines here like this. That's helpful. And you can put lines if you want here, but you don't have to. But there you go. Okay, now what we're going to do is, it says here that my initial concentrations of A and B are 1 molar, so I'm just going to write that in here. Remember that your concentrations for reactions that are in solution are going to be in molarity. And then my equilibrium concentration is down here, and that's 0.120 molar of C. And that's all I have. So remember, what I've got to get in order to calculate K, K comes from these values. That's where K is going to come from. All right, now let's see what else we have. Now, if I have, these are my 2 initial concentrations, if C is not mentioned at all, that means it's 0. If you had an initial concentration of C, then you would have been told that, but it's you don't, so you assume that as 0. Now, what is a change? A change means that something is going to happen. The reaction's going to run its course, and there's going to be a value, a change with relation to the stoichiometry. So A is just a 1, so it's going away, so I'm going to put a negative there because the reaction is going this direction. This one, B, is going away, but by 2x, and then C is coming, but it's adding by 4x. So what I want to do is I basically have to find x in order to solve for these two parts. Now, how do I do that? Well, here's something I have right here. If I add these two rows, or add these two rows together, I'm going to get their equilibrium concentration. So this should be minus x. This should be minus 2x. I'm basically taking the initial concentration and subtracting the change. That's it. And this one is going to be 0 plus 4x. All right, now here's what we've got here, however. I know what this is. So that means that 4x is equal to 0.120 molar. I've got that because I know that concentration. So that means that x is equal to 0.03 molar. If that's the case, I can just plug these in. So that means that this one is 1 minus 0.03, and this one is 1 minus 2 times 0.03. And I put that in here, so that one is going to be 0.970. This one is going to be 0.940. And then, of course, this one is that value. So I'm going to box these answers. And basically, solving for x gave me all my concentrations. Now that I have my equilibrium concentrations, I can plug those into K and solve for K. So let's do that. Make sure I have that here. All right. So Kc is going to be 0.120 molar to the 4th power divided by 0.970 to the 1st power and 0.940 to the 2nd power, and that's 2.42 times 10 to the minus 4. Unitless number, box your answer.